Hi guys, let's figure out how iPhone 7 Wi-Fi circuit works today. Wi-Fi is a type of technology that enables electronic devices to connect to a WLAN. There are two radio wave frequencies used to ensure the working of the iPhone 7 Wi-Fi, 2.4 GHz and 5 GHz. Wi-Fi signal of different networking standards vary in transmission rates, and they all should run on one set frequency based on standards. First, let's take a look at the main components on the Wi-Fi circuit: WLAN RF, Wi-Fi and Bluetooth module. Data transmitted from CPU is first coded by the module, then translated into a certain radio signal. This same signal will then be transmitted via the antenna. The Wi-Fi signal received will also be demodulated and decoded by the module into raw data and then be sent to the CPU for further process. U0700 CPU, which controls WLAN RF, and its communication with the WLAN RF via PCIe bus, also completes the network information transmission work. U1801 PMU, Power Management IC. It provides power supply, clock signal, and enable signal to WLAN RF. Now let's find out how iPhone 7 Wi-Fi circuit really works. First, the charging IC transmits main power supply PP-VDD main to WLAN RF. Once the phone has been turned on, PMU will output the 1.8 volts power supply to WLAN RF, and then a clock signal at frequency of 32.768K. With the Wi-Fi being turned on, PMU will send a register and enable signal to WLAN RF so as to get WLAN RF activated. By means of its inner circuit, WLAN RF will then form a box circuit with L7600RF. The 1.4 volts voltage generated by the box circuit afterwards can be used for internal application of the module. Next, CPU will send a wake-up signal to WLAN RF to get it activated. CPU will also send a driver to WLAN RF via UART bus. By now, WLAN RF is well prepared for work. Next, CPU has to get the PCIe bus function of the WLAN RF activated. To enable the function, CPU needs to send a reset signal of the PCIe bus to WLAN RF. With the signal received, WLAN RF will then enable the PCIe function and ask CPU to provide clock signal necessary for normal working of PCIe. Once the reference clock signal of PCIe has been sent to WLAN RF by CPU, PCIe bus will then get to work. By way of the PCIe bus, CPU communicates with WLAN RF so as to complete the network information transmission work. WLAN RF captures Wi-Fi signal first, then inform the CPU of the result via PCIe bus, and ask users to enter the password of the Wi-Fi signal of his choice. Please be noted that, with the phone being connected to Wi-Fi, but in sleep mode, if there are notifications of alert messages, WLAN RF will send a host wake-up signal to PMU, and screen of the phone will then light up. If the host wake-up circuit goes wrong with the screen being black, we won't be able to awake the screen with power button. For iPhone 7 Wi-Fi circuit, there are two antennas receiving Wi-Fi signals at the frequency of 2.4G and 5G respectively. Here we will take signals received by JL83RF as an example to show you the reception and transmit process of Wi-Fi signals. The reception process goes like this. Wi-Fi signals enter into JL83RF via antennas, then the combiner by means of a match network. The combiner outputs Wi-Fi signals at the frequency of 2.4G and 5G to WLAN RF for further process. WLAN-RF restores the signal into data to be processed by CPU. Then the data will be sent to CPU via PCIe bus. Now let's move to the transmit process. CPU sends data to be transmitted to WLAN-RF via PCIe bus. WLAN-RF modulates this data into proper frequency. By way of pin 5, Wi-Fi signals at the frequency of 2.4 GHz and transmitted to the filter and then the combiner. These Wi-Fi signals will then be sent out by a matched network. By way of pin 66, Wi-Fi signals at the frequency of 5 GHz will be transmitted to the combiner and then sent out. Now let's move to diagnose and maintenance of iPhone 7 Wi-Fi circuit. Once we have confirmed that the fault has nothing to do with external causes, like network, Wi-Fi compatibility, or router problem, network setting of the phone, software version, or exceptional data of the NAND flash chip, we should run cosmetic inspection of relevant area on the board. Still, we will take signals transmitted via JL83RF as an example. If the fault shows up as a signal problem, like weak signal or unstable signal, we can take one level of tweezers as an external antenna and connect with nodes on the antenna circuit one by one. If the signal strength is back to normal with one specific node, then the fault component is the one connected with the node. If all nodes fail, then WLAN-RF might have been damaged or pseudo-soldered, and we need to replace or reboot WLAN-RF. As for other problems related to the Wi-Fi circuit, we need to measure these test points first. 1. C7602 4.2 volts. 2. C1816 1.8 volts. 3. C7603 1.8 volts. 4. R0807 1.8 volts. If nothing goes wrong, detach WLAN-RF from the board and run diode measurement of its bonding pad. If the measured value is normal, then replace WLAN-RF. If the measured value of one specific bonding pad is abnormal, then check relevant circuit of the pad. Please be noted that if we need to replace the Wi-Fi module, we have to detach the NAND flash chip and unbind the Wi-Fi module before replacing. Otherwise, the newly soldered Wi-Fi module wouldn't work. What's more, the underlying driver of WLAN-RF is stored in NAND flash chip. Exceptional data of the NAND flash chip can result in not working of Bluetooth. This kind of issue can be fixed by NAND flash chip repair. Common fault components of the Wi-Fi circuit. Malfunction of WLAN-RF will result in issues like weak Wi-Fi signal, no Wi-Fi signal, Wi-Fi activation failure or Wi-Fi connection failure. Malfunction of W2BPF RF will result in weak Wi-Fi signal, unstable Wi-Fi signal, etc. And this is our detailed explanation of how iPhone 7 Wi-Fi circuit works. Feel free to visit our official website www.rivatechnology.com. See you next course.